Welcome to August 13th LeetCode challenge, set matrix 0. Given an m by n integer matrix, given an element that is 0, set its entire row and column to zeros and return the matrix. Must do this in place. So an in place algorithm is basically meaning that we don't really return anything, we just change and modify the matrix as we go along without giving basically making another matrix in its place. Alright, so given this example 1 here, given this matrix where we have the center cell being 0, and that means that we have to generate or modify the matrix such that we have the rows and columns of that cell to be all entirely 0. Likewise, we have zeros in the corners here. That means that if we modify the matrix to make it all set matrix zeros, that means the rows and columns itself would be zeros. Essentially, if we have a diagonal of zeros, that means the entire matrix that we get out of it or modified would be all zeros as well. So here comes some constraints. M by n, those are the distance, and that's the matrix, the numbers. So yeah, the approach to this question itself is straightforward. However, the only limitation that makes it hard or much more difficult would be doing it in place, and obviously the minimizing the space complexity of it. So we'll start off with the regular intuition approach, which in order we might be able to improve upon that later. So if any cell of the matrix has a 0, we can record its row and column in the ij position, and all the cells of this recorded of the rows and columns can be marked to 0 in the next iteration. So basically it's a 2-pass algorithm, right? We go through it once, we find all the zeros, and then we go through it again and make all the modifications we need to the rows and columns. Essentially it. So let's see, how about we make a pass over the original array to look for all the 0 entries, right? We iterate through the entire matrix, we find all the zeros, and we keep track of where the zeros are, the ij position. Once we find that, we store that, let's say, inside a set. Right? We store that. No, we store the location, and then we're gonna change the row and column to be all zeros, but we're gonna keep track of it though. It's gonna be inside a set. And they're gonna add that to the row and column set. Then finally we iterate through the entire matrix again, and then we just check the rows and columns marked earlier, and then we just mark them zeros, the cells as zeros, or the columns as zeros. So how will you go about doing that? This is our first intuition approach. The first thing we want to do is set up our dimensions. So we have n will be the length of our matrix. Then we have m will be the width of our matrix. Then we're going to set up a rows and columns set. So this is going to store basically our rows and columns that we need to make turn to 0 later. That's going to be set as well. Alright, so first thing we're going to do is iterate through each of these cells. So each for I in range of n, nested within for j in range of m. What we're going to do is we're going to find if the matrix 0, a matrix that cell ij 0, ij is equal to 0. If it is, we are going to add the rows and columns into our set. So rows.add ji, columns.add j. So yeah, that's pretty straightforward. We have a nested for loop here, of course. Next thing we're going to do is iterate through the matrix again, and this time we're going to change each of the rows and columns if they have a 0 in them. So for I in range n, for j in range m, if I in rows or j in columns, then what we're going to do is set the matrix to be basically set to be 0. So matrix at the ij position set it equal to 0. Alright, so we're not returning anything because it's a void function and we're modifying it in place instead. So let's run this code and check this out. Accepted. So space time complexity would be m times n time complexity. Yeah, it'd be big O of m times n, where m is the number of rows and n is the number of columns respectively. And space complexity is big O of m plus n, so the number of rows plus number of columns. So the question asks itself, how do we optimize it? So is it possible to make a constant time and then constant space? The answer would be yes. Let's think of a way we could do that. So instead of instead of doing this in the nested formation, we could do 4-4, right? For two nested for loops, we could do it side by side, which would be a lot easier to save some space complexity. And yeah, let's go about doing that. Let's see. So we have a nested for loop here. I'm actually going to, so instead of using a set, I'm going to use a special function called any. So it's like a product matrix. So any matrix 0 at j that's equal to 0 for j in range of m. Right? So for any cell that has a column equal to 0 for the j in range of m, then I'm going to set that to be rows. And then I'm going to do the same thing for the columns. Any matrix I, let's see, I 0 that is equal to 0 for I in range of n. So I'm basically making the rows and columns a little bit differently. Instead of using a set, I'm using this notation here. So since we have 0 already included, I'm just gonna change the range to 1 to m, just to make it a little bit more convenient. Yeah. So instead of adding it to the rows and columns, what I'm gonna do is set matrix at position I 0 to be 0, assign that, and then set matrix at 0 index j, assign that to be 0. So I'm changing it as we go along. And then I'm going to run another for loop actually. And then for this one, I'm going to also change the range. And then what I'm going to do is copy this loop here. So we do have to increase a little bit of the time complexity in this one, but not by a lot. So what I'm going to do is do another range here. So actually I'm going to look for if matrix at position I 0. So this is a cell I'm looking at, times matrix. So this is so we don't count it twice, I should say. Matrix 0j is equal to 0. And then that cell is going to be still 0, essentially. So matrix I j assigned to be 0. Right? Yep. And this, I'm just going to erase this function here. So now we have basically a constant time space solution. So we do a for loop there. No, wait, we don't need to do this. So if rows exist, what we're going to do is for each matrix 0 I, so we're going to make that assigned to 0. Now if columns exist, then for each j in the range of m, n I should say, then the matrix at j0 will be assigned to 0. So yeah, this is going to be a constant space complexity. Let's run the code. Alright, accepted as well. So time complexity is still an m times n, because we do iterate through each of the cells first to find the index 0, but this time we just change it a little bit differently. Alright, that's it. Have a great day, guys.